Welcome to NPTEL online course on Fractal and Multifractal. So, in these lectures we are going to discuss the parameter estimation of fractal interpolation function. In the last lecture we have clearly described what is the use of each parameter which appears in the fractal interpolation function. So, this lecture will discuss the how to estimate the each parameters. Now, so in the fractal interpolation of the form Li and Fi is defined in the previous lectures for the given set of data point. So, here the given data points are, once again I am writing given data for xi and yi. So, for this given data point to find the fractal interpolation function, we are using the iterated function system of the form Li of x equal to aix plus bi and fi of x comma y in the form alpha iy plus qi of x, where this qi we are taking as the linear case. Qi of x we are going to take cix plus di. That means we are going to take qi as a affine mapping. That means the linear case we are going to discuss. So, fi of x comma y equal to alpha iy plus cix plus di. So, this form we are going to discuss how to find this constant value ai bi. Then the iterated function system wi of x comma y, in this mapping wi of x comma y will consisting the mapping li of x and fi of x comma y. So, this can be given in the matrix form here. That means wi of x comma y can be written in the form of all ai 0 ci alpha I and x y plus in the form of bi and di. Now, this is nothing but we can write in the matrix form. One can get aix plus bi comma cix plus alpha I times y plus di. So, this form one can get fine. Now, we know that this Li has certain condition for the joining the x direction and Fi has a certain condition for joining the y direction, so that this Wi satisfying the endpoint condition. So, this Wi of x1 and y1 usually satisfying xi comma yi and wi of xn comma yn will join, should map with the xn comma yn. So, by the endpoint condition of Li Fi, the wi map the endpoints xi to the xi yi and xn yn to the xi plus 1 yi plus 1. Now, one can replace x and y with xi yi, and what will happen, and one can check instead of x and y xi plus 1 and yi plus 1, one can substitute and check what will happen. Fine. So, this is the two condition. If you are taking wi of x1 and y1, wi of x1 and y1, we must get xi and yi, whereas this is in the form of aix plus b. If you are taking xs x1, then this form one can get ai x1. For the y, one has to get in the form of fi in the form of alpha I y plus cix plus di. So, one can get alpha I y1 plus ci x1 plus di, which is equal to xi comma yi. So this coordinate will equal to this coordinate, and the second coordinate will equal to the second coordinate. So ai x1 plus bi is yes, I missed the bi, plus bi must be equal to xi, and alpha I y1 plus ci x1 plus di must be equal to yi. And similarly, if you are taking this condition, that means xn yn equals xi plus 1 and yi plus 1, can apply wi, and here then one can get ai xn plus bi, and this one when you are applying yn here, then alpha I yn plus ci xn plus di, which is equal to xi plus 1 and yi plus 1. Now again with the same thing, here this coordinate equal to this one and this coordinate this equal to this one can get ai xn plus bi equal to xi plus 1, and alpha I yn plus ci xn plus di, which is equal to yi plus 1. So now we get the 4 system of linear equations. Now we get the system of 4 linear equations. Now just look at the first 2 equation. The first 2 equation, it involving only and a and b. So by solving these 2 equation, one can get the value of ai and bi. Let us try to find what is ai and bi, then we will move to find the ci and di. So from these 2 equation, one can get, if you are subtracting these 2 equation, for removing the b, so ai x1 maybe ai xn minus ai, subtract this 2 here, ai xn minus ai x1, this b will cancel, which is equal to xi plus 1 minus xi. So that one can get ai value as xi plus 1 minus xi over xn minus x1, which we already discussed. This value is less than 1. So in the li of x comma x equal to aix plus bi, we are obtaining ai values this as like the homeomorphism function we are defining on the xn x1 comma xn to x1 to xi to xi plus 1. This is li. So from this iterated function system, we obtained ai values like this one, this is less than 1, therefore this ai will act as the contraction in the horizontal directions. Now we will try to find bi. Simple, the bi, you can replace the bi value here, ai x1 plus bi equal to xi. Here bi one can obtain by taking xi minus x1 times ai. So xi minus x1 of this value xi plus 1 minus xi over xn minus x1, then one can get to the bi value. So what is this xi's are? Xi's are the given data point. If the given interval, this is x1, this is xn and xn, then x2 and so on xi and xi plus 1, it will be given to us. Xi and yi will be given to us. There is no other value. So one can get ai value by using this formula and bi value by using this formula. Now the ai we are finding here and bi one can get here. Now you can see how to find Ci and Di from these two equations, because initially we have the 4 equation. By using these two equation we obtained A value and B value. Now we need to obtain C and D value from these two equation, but one can observe that x1 and xn will be given to us, y1 yn will be given to us. We can take it from the data points, as well as the yi2 yi plus 1 will be given to us. So now we have the 3 constants Ci Di. So this Ci Di alpha I, we have only 2 equations. So this system is inconsistent, so that we are predefining this alpha value, because it is control the data point in the y direction. We need to predefine this value. This value we know that it lies between -1 to +1. So one can predefine this value, that means this is a known value, therefore this system becomes the consistent system. We have find the unique solution of these two number. So depends on the alpha, we are finding Di and Ci. So if you are changing the different alpha, we can control the curve in the y direction with the different manners. First let us find the constant Ci Di by predefining the alpha I value. Now for the simple case, one can subtract this equation minus this equation Ci x1 plus alpha I y1 plus Di yi plus 1 minus yi. So always we can subtract the higher to lower. Then one can take Cn as common here, Ci is common here and here, so one can get xn minus x1. Then alpha I one can take common, then one can get yn minus y1 here, and this Di will be cancelled in the both the case. Then yi plus 1 minus yi. So one can get Ci value as taking this term the right side, then yi plus 1 minus yi minus alpha I times yn minus yi over xn minus x1, one can get the Ci value. Now we obtain the Ci value, the Ci value involving the pre-parameter alpha I, and similarly now we obtain the Ci value. Now the Ci value you can replace, substitute here, then one can get the Di value. So for finding the Di, substitute the Di value in this equation. We can substitute here also, but I will substitute here. Then Di equal to yi minus Ci x1 minus alpha times y. Now just replace the Ci value and take the common term xn minus x1, then finally one can get this one, which gives Di value as this one. Here Di also depends on alpha I, Di value also depends on alpha I, and one can observe that for finding the Ai, Bi, Ci, Di, we are dividing all the numbers by xn minus x1. That means the whole interval we are just dividing by the whole interval length. Then here alpha is the pre-parameter, it lies between -1 to +1, and xi and yi will be given in the problem. That means data points will be given to us. Now we are ready to find the fractal interpolation function of the form Li of x equal to aix plus bi, and fi of x y equal to alpha I times y plus cix plus di. Now if depends on the a, b, c, d, one can get the iterated function system in each interval. Since see let me explain here. Suppose I have the 3 data point x1, x2, x3. Now the data point are x1 comma y1, x2 comma y2 and x3 comma y3, 3 data points. So we need to find the L1, L2 and F1 and F2. For finding the L1 and F2, for finding the L1, we need to use this 2 data set. That means L1 will act on this interval, L2 will act on this interval. That means L1 is a function from x1 xn to x1 x2, whereas L2 is a function from x1 xn to x2 x3. So L1 map contract this whole interval to here, this will map here, whereas L2 function contract the whole interval to this interval. So for finding the L1, we need to use data points x1 y1 and x2 y2. For finding the L2, we need to use this data points. Similarly, for finding the f1 f2, we need to use this 2 data point for f1 and this 2 data point for the f2. So if we have the n number of data point, then we need to find the n minus 1 number of L1 and L and F for each subinterval. Now we will check what is the role of this parameter. The transformation Wi map the line segment parallel to the y axis to the line segment parallel to the y axis. Moreover, if the length of the line segment L is L, then the length of the line segment after applying this Wi map is alpha times L. Suppose we have the line segment like this one with the length L. If you are applying the map W, it will map this line segment parallel to the y axis here. It will map like here, that means it will shrink here, this will shrink here. That is the role of alpha. Now for all, in other words, the ratio between the length of the line segment L and Wi of L is modulus of alpha I. So if you are choosing alpha value is minus 1 to 1, with respect to the alpha, this ratio will vary. If you want to take this as positive, it will goes like this one, whereas this is there is a minus 1 to less than or equal to 0 is possible and 0 to 1 is possible. If it is positive, this is in the positive direction, it will shrink. If the value is negative, it will shrink like this one, in the negative direction. So the ratio between this line segment and this line segment is modulus of alpha I. We say alpha as the vertical scaling factor of the, so that we are already as discussed, alpha is called the vertical scaling factor of the transformation Wi. The free parameter alpha I determine the shape of the fractal interpolation function generated by the IFS given in 1. If alpha is 0, one can produce the piecewise linear fractal interpolation function, so that we are calling the fractal interpolation as the generalized case of classical interpolation function. Now the role of alpha is explained here. This y direction is explained through alpha. Here this direction is shrink with respect to the ai value, because ai value we are taking as in the each subinterval xi plus 1 minus xi by xn minus 1, which is less than 1. If the whole interval, for example, here we are taking 4 data points x1, x2, x3, x4 and corresponding y1, y2, y3, y4 value. Here we are giving the example for how the mapping acting on the interval x2 to x3. That means what is the role of L2 and F2 here? Now, if alpha controlling the y direction, then this value, see this value, this maps to here and this point maps to here, so that we are getting these values. So, this length will be determined by the factor ai, which is also less than 1, so that here xn minus x1. So, this will determine the length of the horizontal line. Okay, fine. Now, let us explain this role of alpha and ai and other parameter through the example. Let us consider the data point 0, 1 by 5, 1 by 2, 1 by 2 and 1, 0 we can consider, not this is 1 by 2, we can consider 0, not a 1. That means this value which already we discussed in the classical interpolation, we consider the 0, 0 and 1 by 2, 1 by 2 and 1, 0. This is not 1 by 2, it is 0. So, this is 1, this is 0, this is 1 by 2, 1 by 2, here it is 1 by 2, 1 by 2. Fine. And fix the vertical scaling factor alpha equal to 1 by 2, alpha 2 as 1 by 2. That means we have this point 1 by 2, there are two intervals here to here. So, in this interval we are fixing alpha value as 1 by 2, this interval also we are fixing alpha value as 1 by 2. So, now we can find the AIX plus BI. Similarly, Fi of x comma y we can obtain as alpha of y plus Ci of x plus di. We know how to find the Ai, Bi and Ci and di. Here the alpha value we are fixing as 1 by 2 in the both the interval. Then one can use these formulas given in the equation 8. One can find the A, B, C, D values Ai, Bi, Ci and Di. So, one can get the unknown parameter values as A1 as 1 by 2 and B1 as 1 by 2. Just replace the values here. One can get A1 and A2 values here and B1, B2 values here and C1, C2 values here and D1, D2 values here. Now, what is the IFS? Li of, now we need to find what is the L1 of x. So, L1 of x1 is A1 of x plus B1, which is equal to 1 by 2 x plus B1 is 0. Likewise, L2 of x equal to L2 value is again 1 by 2 x plus B2 value is 1 by 2. So, this is my L1 function, this is my L2 function. Then what is f1 of x comma y? The f1 of x comma y we need to define in the form of alpha iy plus Cix plus di. Here the alpha I value is 1 by 2. So, 1 by 2 y plus C1 is 3 by 10 x and D1 value is plus 1 by 10. This is F1 and F2 in the form from this data point, the F2 value again there is no change in the alpha, we are taking the same alpha plus Ci, the C2 value is minus 3 by 10. So, here minus 3 by 10 plus 2 by 5. So, now we have the L1, F1, L2, F2. You can observe that this is 1 by 2 and here also it is 1 by 2, x by 2. This is the contraction factor, here it is 1 by 2. So, L1, L2, F1, F2 all are contraction and the transformation, the shifting parameter is here it is 0, there is no shift. So, that Now you can observe that there is no shift in this direction and the x direction with one while apply, not a shift means here we are taking the interval 0 to 1, 1 by 2. So this 0 maps to 0, then 1 maps to 1 by 2. So no need the shift, already the endpoint is mapped, the role of bi is 0, whereas here after applying 1 by 2 on 0 comma 1 is just taking plus 1 by 2. So it will shift the whole interval 0 to 1 by 2 and 1 to 1 here, 1 will come to here, then after that applying b value it will move to here. So the first map will map the 0 comma 1 to the 0 to 1 by 2 and second map the 0 comma 1 to the 1 by 2 comma 1. Now this is the 4 mappings. Now the fractal interpolation function generated by this iterated function is depicted here. You can see we need to increase the iteration, one can get this type of iterated function system. Now you can see in the linear interpolation we are getting this type of curve, line joining two data points. This is the interpolation we are getting. Now we are, while choosing alpha is 1 by 2 in the both the interval, we are getting this type of curve. Now here I am taking both are positive and equal. Now you can check if I am changing just alpha is minus 1 by 2 and plus 1 by 2, then because the alpha value will create the effect on the y direction, therefore there is no change in the Li function. So in the Fi function it will change, like here x value there is a change and the 1 by 2 is changed and the Ci value was changed and Di values are changed, because the Ci and Di is fully depends on the alpha values. Therefore the only changes in the Ci and Di, then the fractal interpolation corresponding to this parameter corresponding to this alpha value we are getting like this one. You can see the previous example we are taking the alpha value as plus 1 by 2, in the second interval also plus 1 by 2, we are getting the figure like this one, previous one. Now if you are taking minus 1 by 2 we are getting the figure like this one. You can see this is the classical interpolation. When you are approximating the data we can get this line, whereas fractal interpolation function you are getting this one. So one can observe that the data point is same for us, 0 comma 0 and 1 by 2 comma 1 by 2 and 1 comma 0. This is the data points. The data point is same, whereas the Qi of x we are taking as the linear case, Cax plus Di, this is the case, whereas if you are changing the different alpha we are getting two different curves, entirely two different curves. Now if you are taking alpha 1, alpha 2 both are 0, which is coincide with the classical interpolation function which is given here. So one can observe that the scaling factors controls the y direction and it entirely influence the shape of the fractal interpolation functions. So in next lecture, what is the behavior of different scaling factor when the given data point is given, we will discuss in detail. So I will end the session here. Thank you.